So this is the sample table of the Laplace transform of some standard signals. So you just have to memorize them. So if the signal is impulse, this is the Laplace transform of impulse. It's just 1. Step is 1 over s. Ramp is 1 over s squared. Exponential is 1 over s minus a. Cosine is s over s squared plus w squared, and so on. Okay, so the properties of Laplace transform are the following. We have first the linearity. When we say linearity, basically it means you Laplace transform each expression individually and they are only separated with operations. So for example here, as you can see, they are separated with addition, right? You Laplace transform, you convert each expression in Laplace transform individually, okay? Individually, as you can see here. So our example, find the Laplace transform of the function u of t plus 2 e raised to negative 3t plus 3 sine 2t. Okay, so we have here the table of Laplace transforms. So the u of t is simply just 1, right? 1 times u of t, right? The constant is just 1. Therefore, when we find its Laplace transform, that is just 1 over s, as you can see here. 1 over s. Now for here, for 2 times e raised to negative 3t, we just have to separate the constant. So 2 times the Laplace transform of this one, e raised to negative 3t. Now, in here, as you can see, it's e raised to at. So our a is the negative 3. Therefore, our formula is 1 over s minus a. Therefore, it will become 1 over s minus the a, which is the negative 3. So it became like that. 2, which is the constant that we have set aside earlier, 2 times 1 over s minus a. Which in here, since negative times negative, it became positive. Okay, next for sine 2, for 3 sine 2t, this is the constant. We just have to set that aside and then Laplace transform this sine 2t. So our sine is a over s squared plus a squared. So let's identify what is a, or so the w. So our a is equal to 2. As you can see, sine 80, and here sine 2t. Therefore, the a is just 2. So let's just substitute the a. So the formula says a over s squared plus a squared. Therefore, we'll just substitute that. It will become 2 over s squared plus 2 squared. Simplify, 1 over s, 2 over s plus 3, because it's negative times negative, plus 3 times 2, which is 6, s squared plus 4. That's the final answer. Now let's proceed to the other property, which is the time scaling. This happens if our function is accompanied with a constant. So usually it's just f of t, and then usually other expressions. Now in here, in time scaling, we have a constant together with the function. So for example, we have f of 2t and so on. So if that happens, if that's the case, this is our formula. F of at is equal to 1 over a, this is absolute, and then the Laplace transform of the function, and all s should be changed into s over a. Okay, so in our example, we have, if the Laplace transform of f of t is equal to 1 over s plus t, find the Laplace transform of f of 2t. So the Laplace transform f of t is already given. Now all we have to do is use the formula, recalling the formula. F of at is equal to 1 over the absolute value of a, the Laplace transform, and all the s should be changed into s over a. Now identify first what is a. So our a is equal to 2. Therefore, it will become 1 of 2 based on our formula times the Laplace transform, which is already given, 1 over s plus 1. And recalling, the s should be changed into s over a. Therefore, it became s over 2. Now, we just have to simplify this one. We should remove the denominator here in the denominator of this one. So, in order to remove that, it became s plus 1. So, s over 2 plus 1, multiplied it by 2 over 2 so that they will have the same base. Okay? Because the property, recalling your property, so this one will just become s plus 2 over 2 because they already have the same base. Now, this will just cancel out and we will have this answer. Next property, we have the time shifting. This happens if our function was time shifted. Okay? So basically, if the other one was multiplied, as you can see, the a was multiplied with the t, our variable, then in here, it was either added or subtracted. That is, it shifted, right? So our variable t was shifted. So that's time shifting. Now, what we're gonna do here is follow these formulas. To avoid confusion, I think we're just gonna follow this, the positive one. So, as you can see, if the shifted TO was positive, then the TO, the exponent of then our exponent is also positive. Now, here in our example, we must find the Laplace transform of u of t minus 2. So it's time shifted, as you can see. So recalling, the first one that we have to do is to identify the base function or the unshifted version of our function. So this one, if TO was removed, what is the base function? That will just become u of t, right? Now, based from our formula, that base function, we should find its Laplace transform. So what is the Laplace transform of u of t now? We have here u of t, or simply 1 times the function that will be 1 over s times e raised to s to. Okay, so since in here we have a negative to, then negative s will have negative 2 to, or simply e raised to negative 2s. Okay, so that's the final answer. So again, the most important part is to identify the base function or the unshifted version of the function, and then Laplace transform it, and then follow the formula. Now, for our next, we have the frequency shifting. Now, we will gonna use it if we have this function. It comes with an exponential function, or e raised to sot f of t is equal to. So this is the formula, f of s minus s sub o. So as you can see, if our function is positive, then what we're gonna do here, the sign here will be negative. Okay, so let's apply it in an example. So find the Laplace transform of the function e raised to negative 80 cosine wt. Okay, so the first step again is to find the base function. which is the function that is multiplied to the exponential function. So this is our exponential function and this is our base function. And we should find its Laplace transform. So recalling, the Laplace transform of cosine 80 is simply s over s squared plus a squared, right? You can see. So our w here is considered as our a. Sorry, it's considered as our, no, we just have to let the Laplace transform. Originally, it's s over s squared plus a squared, right? But to avoid confusion with the exponential function, which is also given with a, we'll just change it into w for now, okay? So it will become s over s squared plus w squared. This is the Laplace transform of cosine of wt. Now, based on our formula, from the Laplace transform of our given base function, the s should be changed into s minus the s sub o. Okay? So we just assume that s sub o is a for now. Okay, so s sub o is equal to negative a. So from this Laplace transform, all of these s will be changed into s plus so, but in this case, so is equal to negative a. Sorry. So to avoid confusion, let's just disregard this one and follow this. Always the positive. So if the s sub o is positive, then the sign here will be negative. Okay, so in this one, so is equal to negative a. Okay, now we're gonna follow that for the function of the Laplace transform, we're gonna change it into s minus s sub o always. Okay, so in here, as you can see, s minus s sub o, but our s sub o is equal to negative a. Therefore, we got this one. Then for this one, the s squared, we just changed it into s minus the s sub o, which is negative a squared plus w squared. Simplifying that, we'll get this. Okay, for our last property, we have time differentiation. This happens, so if we have these functions, if we have d over dt and a function, and then d squared over dt squared and a function, and so on. So if we have d over dt, we'll only have f of s minus f of 0. So the first exponent of s in the initial one matches the exponent of our d over dt. So as you can see, if d over dt was raised into 2, the first exponent of s will also be 2. And then that will decrease until it became 0. As you can see, s squared of f of s minus s, that became 1, and then this became s raised to 0. Therefore, it became 1. Therefore, it was not 310. Let's apply it so that we can better understand it. For example, given the following differential equation, find the Laplace transform of g of t if all initial conditions are 0. Okay, so our initial condition is the f of 0. It's considered as initial conditions. So for this example, as you can see, we have d squared y of t over dt squared. So this one, we are based on our linearity property, we are going to Laplace transform each. Therefore, it will gonna be a long method, long solution. So this one, the Laplace transform of this one will be s squared times the capital Y of s. Remember, from time domain, So from time domain, which is y of t, it became a frequency domain, which is y of s. It's capital, okay? Remember that. Now next, the so let me just correct this one. So this one was already from time domain, it became in frequency domain. So it became capital. And then it became the initial condition f of 0. And then from that, we will have f prime of 0. Now, if there's a following, it will become f double prime of 0. And if there's a subsequent, we have f triple prime of 0, and so on. Okay? So if this one is raised into 3, it will be s cubed f of s minus s squared f of 0 minus s f prime of 0 minus f double prime of 0. So that, okay, I just corrected that one because it's wrong. Okay, now, as you can see here, s squared y of s minus s y of 0 minus y prime of 0 plus, since we have a constant, we'll just separate that, 12 times s y of s minus s y of 0. Okay, as you can see, since the exponent of this is just 1, then the exponent of the initial s will be 1 as well, multiplied by the frequency domain minus the decreasing. Okay, I just could disregard this one. Okay, it should be s raised to 0, therefore it will become 1, plus 32 times y of t. Since there is no dy over dt, the exponent of dy over dt is just 0, then the initial s will be raised to 0 as well, or simply 1. So 32 times y over s is equal to the Laplace transform of this one, which is just 32. U of t is just 1 over s. Okay, that's the Laplace transform of u of t. So based from the condition, all initial conditions are 0. So all initial conditions, including the y prime of 0 and so on, are 0. So let's just combine all of this. So what left of us is s squared y of s plus the 12s y of s, as well as the 32 y of s is equal to 32 over s. Now we just have to isolate the y of s, and then we will have 32 over s times this function. So now this is our Laplace transform. This is our final answer.